Okay, let's go back to that. Oops. Okay, welcome back. Sorry, and your name is Sergio?
Serge. Yeah.
Serge. Okay. Hey, everybody. So, Serge asked a question a couple minutes ago. He's like, hey, I tried running that survey program and it blew up. And so we've got him on a Google Hangout, and he's sharing his desktop. And so let's work through this with him. Okay, so you ran the command line, and big blow up. And what is it saying? It's saying unsupported class version error. What do you think that means? Yes?
Maybe the wrong version of Java set as the default.
That's probably a good place to start, right? It had the word version in it. Wrong kind of version. And then class. Okay, that's some of the class version. So yeah, excellent. He did a Java-version. And what version are you running? 1.7. So you want a 1.8. And so let's see here. This is on the school's. This is on the PDX machine. Okay. Let's see here. Who here is a cat? Anybody from the cat? Yay. Okay. So let's see here. He needs to do the add package or something.
Yeah, there's a tool for that. I'm not sure the exact syntax.
Okay.
Yeah, I know. I remember.
Okay.
The instructor showed that in class once, but
Cool. I'll see if I can do it in my environment real quick. Let's see here. We'll quit out of this guy, and then I'll SSH in. So let's see here. Actually, I don't use. Is it add package? I can never remember.
Yeah.
Yep. Okay. So try that. No, probably. I'll go back to
Very
the.
good.
Hey, wait a second. Let's get you up on the screen here so that because you probably be the first one. Oh, look at that! Wow. Takes me back to the late '80s. Java 7, Java 8. Haha. So was that space that you just hit?
Yep.
Okay. And maybe return for okay?
Nope.
Nope. Okay.
Tab.
Tab.
Yep.
Oh.
Fine.
There you go. Your package selections haven't installed.
Okay. So if I-
Okay. So do that. Do that. Do which Java? Okay. Or Java version. No, you might need to log in, log out again. Okay. So restart your environment. It's the close up of my face. That's freaky. Yeah, it's an old picture of me too. Oh, and we lost all the largeness of the.
There you go.
Okay, well now it's Java. Yeah, don't worry. That does say Java 8 up there. Okay, now let's try running the command again.
That worked.
Okay. Oh, while we get here, what is your first name? Actually, no, you don't need to. Because you need to put in your social security number and things like that. Don't do that.
Oh.
So anyway, not your student ID.
All right.
But anyway, okay, cool. Why don't you hang up from the Google Hangout? I'll leave it open. I posted the link to the community in case there's anybody else that wants to jump on. Yes.
Sorry, I have another question.
Yeah.
So since we're using Java 8, do you encourage use of Lambda expressions?
That would be awesome. So yeah, right. Use the full power of it. And like I said, I don't have any content up there right now, but I'm hoping this weekend to. Actually, the slides are up there if you go find them. But yes, please feel free to use the. How do I get a full screen mode? No. Anyway, yes, please use Java 8 and any of the standard libraries and stuff. Yeah, it'll be a good opportunity. Okay. 649. I want to do a little bit more with the cones, and then we'll talk about other things. Okay. One more to show you guys. Okay, what do we know? About equality. So, Command N, and I can abbreviate with capital A, capital E, about equality in the beginner one. Okay, so let's walk through one more of these and move on to other things. Okay. Double equals test if two objects are the same. Okay. So let's see here. What have we got? An object, which is a new capital O object. Same object, which is that object. Assert that object equals same object. True. Okay. Object equals new object. False. Okay. Let's see what it says. Yep, equals method by default test two objects are the same. Okay, next one. You got an object. Does it equal itself? Okay. Does it equal another empty object? Yep. Okay. Equals method can be changed by subclasses to tests. To tests if two object. Oh, I think it should be that. Okay, I don't know what that means. Equals method can be changed by subclasses to tests if two objects are equal. Perhaps. Okay. Bad English. Okay, so I have integer 1. Does that object equal itself? Yep. Are there any cases in which an object wouldn't equal itself?
False object.
Would false equal itself?
It's evaluated slightly different.
Ah, if it's evaluated slightly different. What would do that evaluation?
Well, I was thinking like a time object where we're going to evaluate the right side of the left or vice versa, so that it returns something different. I don't know.
Okay, somebody else? Ideas? Well, if you had a class whose equals method was wrong, right? You can write it, right? So if you overrode equals, always return false. If you had that object, does it equal itself? No, it'll never equal any other object. You probably wouldn't override it to equal false, but if you had a bunch of logic there and that logic had a bug in it, yeah. So what do you do to prevent that kind of thing? Write a unit test. Yes, write a test. Okay, so object always equals itself. Does it equal this other new integer of 1? What do you think? True? And why do you think that? The integer class and all of the primitive wrapper classes override the equals method to compare this object to another object, and they say, oh, if that other object is an integer, capital I integer, and its int value is the same as my int value, then we're the same. And you kind of want that, right? So the equals method is a method just like any other method. It can be overridden so equals is inherited from Java lang object, and it's up to subclasses to override it and appropriately and to provide the appropriate semantics. So a number of objects, certainly the ones in the standard API, everything from the primitive wrapper types like capital I integer and string overrides the equals method, but also things like in the collections API like hash sets and stuff. Yep, their equals method is overridden to provide the expected semantics. So if you have a set with, or maybe a better example is like an array list with 1, 2, 3 in it, and you've got a different array list with 1, 2, 3 in it, those are going to be equal. Where's the equals method used? I mean, why would you want to do that? I mean, yes, you can write a cone to do it, but like in your programs, where would the equals method be used? I can't hear what you're saying.
Condition statements.
Condition statements, right? Okay, you are comparing to two objects. String convert, did I hear it? String compare, right? Yep, comparing two things let's say you're ordering objects, and then you can use the compare to method. If you with a comparable interface, say, hey, I am greater than or less than this other object. Yeah. Sorry.
You might want to do like a check if you have like an expensive copy operation for some kind of class.
Right. Yeah. So before performing some operation, you want to check to see, well, have I already done that, or does this collection already contain this object before I go and write a whole bunch of data to my database? Good. And actually, yeah, that's what I was driving at too. So the standard collections, so your array list, your hash sets, and everything like that, use the equals method. They also use the hash code method when they need to hash something to populate your hash table, to figure out whether or not your set contains unique elements, right? So if you have a set of integers, and in a set, every element in the set is unique. In order to determine, and you want to put another integer in there, well, you need to determine whether or not that integer is already in the set or not, and so you use the equals method. So you compare this incoming object with what's already there. If it's not already there, then I'll add it. Otherwise, you'll forget about it. Anyway, fun with the equals method. And finally, okay, a couple more. Objects never equal null. False. And objects always equal themselves. Yeah. And so, let's see here. Can I drill into this? Oh, cool. I've got source code. So IntelliJ downloads the source code for the standard Java API. So here is the implementation of the equals method on Java Lang object. And look, all it does is say, hey, does the object that I'm comparing myself to equals this? Right, so that's the default implementation. Yeah, it's always fun to like go look at the source code for the API standard API classes. Okay, let's check this in. Okay.
What was your shortcut to look at the source code?
Oh, I hold down. There's a couple of them. I hold down Command, and I click on the name of the method. If the cursor is over, you can also say Command B on the Mac, and then I think this is navigate to declaration in the menu. Yeah, good question. That's a good question. 5 points for Gryffindor. Okay. I just wanted to say that. Okay. Okay, what's next? So those are the cones. Oh, okay. I'm sorry, I haven't quite finished talking about them yet. Gee, Dave, we just saw a bunch of code, and you get to do the rest. So the cones, that's just the beginning of them, and there are a lot of them. And they get more difficult than this. And so then this project isn't due until, well, basically a month. And so what I strongly recommend is that you start tonight or tomorrow, start going through them. They're meant to be teaching to get you experience with sort of a broad swath of the language, maybe different things than you would encounter, well, you would encounter just working on the projects. And so it's also a good first test of making sure you can get set up with Maven and your IDE of choice and things like that. And so after you have completed them, and well, you'll know because the little command line program will tell you. Then use something called the submit program, which we'll talk more about next time, to submit them like that. Okay. Any questions about the cones before we talk about other things? No. Okay. Cones. Okay. Let's talk about test-driven development. Oh, let's see here. Am I recording the system? Let me pause. Okay. So, how many have heard of test-driven development before? Yeah, most people have. How many of you have written a unit test before? Yeah, about the same amount. It's kind of a shame, but now you'll get a chance. Boy, sort of starting 15, closer to 20 years now, software developers, some very influential software developers, started evangelizing something called extreme programming. We had, this was sort of like the late 90s, the internet was coming into its own, and developers found that that there was real value in being able to release code quickly. In years past, if you sort of think about like the PC revolution, the way you got your code to your customers is that you emailed them a floppy disk, or you're running IT in a big bank, and there was this one monolithic system, and you were using a project management technique that had like long life cycles. You worked on something for years at a time, and then you sell the requirements up front, and you said it would take 2 years, and then 5 years later, half of those requirements are finally done, but you're about to lose your funding, so you release it anyway, and it's all buggy and it was awful. And they realized that there's got to be a better way to do all of this. And so through a lot of experimentation and some lucky discovey, they realized a couple of things. And one of those was that, boy, if you write automated tests, you can have a lot more confidence that your code works, and so that allows you to go a lot faster. Because you can very easily verify that when you've made a change, it hasn't broken anything. And there's real value in that. And what it's evolved to is a school of thought and a set of practices called test-driven development, where what you do is you write a test first, see it fail because you haven't implemented the code that it tests, right? But you write your test first, and the test really communicates what you expect your code to do. It's like, okay, well, I'm writing. Well, we'll see. We'll write a student class, and it's got some behavior. And then so you write your test, and it passes. And then you write the code that it's supposed to test. You basically implement the functionality, and then you run your test again, and you fix the implementation until it passes. And then then you got working code, and then you take a look at the code again and say, well, is there a way I can improve it? Can I, make it easier to read? Can I maybe remove some duplication in the code? That's called refactoring, right? It's like taking your code and making it better and polishing it up. And then you make those changes and run your test again and make sure everything still passes. And if it doesn't, fix it. And then you can go on and write another test and start all over again. This is called the red-green refactor cycle. And that cycle is discussed here in a little snippet from a guy named Bob Martin. So Bob Martin is industry luminary. I don't know what you call him. And he's written some really great books over the years, some really great code over the years. In particular, there's a book that he wrote called Clean Code and the Clean Coder. Maybe some of you have heard of it. And it really talks about software craftsmanship. And really, it's not about a language. It's not about a library or a framework. It's about what can you do as a developer, as someone who codes professionally, to code responsibly, to code in a way that you will write code that lasts, that is that someone can pick up after months, maybe you coming back to your own code, and have it be something that can involve, something that can be reused, and something that's pleasant to work with. Might sound kind of fluffy, but really it has very important implications. Having code that can be easily evolved, having code that can be that is demonstrably safe and secure and has quality is valuable, because code that's fragile, code that breaks real easily, or code that can't be reused, well, that's expensive because you got to go fix it, or you got to throw it away and start over again. So anyway, he's built a little industry around clean code, and he has a series of videos that you can purchase called the Clean Code videos, or whatever it's called, off on his website, that I highly recommend. I think the personal licenses are on the order of $10 or something like that. Probably makes a good Christmas gift. Or whatever. But it's the kind of thing that if you learn well by watching videos, which I tend to, they're kind of cheeseball at times, but they actually contain a lot of good stuff. Anyway, there is this free snippet here that he has online all about test-driven development. And I'd like to show it to you now, and then we can talk about it.
It's time for the red-green refactor cycle, and I am in the red phase. I must write a failing unit test. All right, what test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red face. The next test, well, I know I want to write that roll method. All right, test, can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll, what should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? Oh, I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes. And now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Okay. Coding. Perhaps a non-native English speaker, or a fisherman. Okay. What did you think? What did you observe? Huh? You want that hat? Yeah.
So one of the things I didn't like is that he wrote one of the tests and then just kind of deleted it. And it's a personal thing. I don't like to write code that I'm not use or delete.
So yeah, it was interesting, right? He writes this really simple. I think he used the word degenerate. Yeah. test, and all it did was create a new object. Didn't assert anything about that object. Why would he do that?
Because that's how the process works. You look for everything and keep the cases.
Yes, you do the simplest thing, but why? I mean, really, is it just wasting time? Is it just like, hey, I like typing stuff, get paid by the keystroke? What does it tell you?
He was testing the specifications, like what he wants to do first through the test and then.
Right, yeah, in the test, it sort of had the specifications, and certainly when we got to like the second and third test, where it was actually asserting something, it's like, okay, create the new game and make sure I can do something. While it's true that he ended up throwing that away, I think in the moment it sort of did say something, right? So he called the new constructor of game. Now, granted, the constructor didn't do anything, but he called it just to make sure, it's possible that you call a constructor, maybe it blows up, maybe it throws an error, and unless you actually exercise it at runtime, you don't know. And so I think that's sort of from a philosophical standpoint why you would do something like that. But then he refactored it, and so it was a setup method that called the constructor. So not only did he remove that code from that test, but now you had the setup method which executed that same test. So you can imagine maybe minutes or hours later, he does add something to the game constructor that I don't know, goes and reads from a file or does some big hairy computation that could blow up in some sense. That could blow up somehow. But he could still be confident that code is being exercised as part of his unit test. So yeah, threw some stuff away. What else do you guys notice?
In the score testing,
Mhm.
I think the score method was supposed to return the actual score of the game, but he only wrote a test to make sure it was zero, so he only wrote a function to return zero.
Right. So like when he went to test the score, he wrote the test first, which meant that he called the score method on the game. Score didn't exist. He created the score method. It returns a value. What value did it return? Well, the IDE filled in 0. And he said, wait, before he did that, he had to return -1. Why did he have it return -1? Right, to see the test fail. And actually, that's important, right? You want the test must run red, right? So you must you want it to fail. Well, why do you want it to fail? Right. So you want to see it. It's not so much to see it fail, but seeing it pass after it fails. Right, so that you can put your code, the code under test, into a state that you know is wrong. So instead of returning -1, another thing you could have done is just thrown a not implemented exception and saw that yes, it failed. Because sometimes when you're writing a test, you're not really exercising the functionality that you think you are, right? And so sometimes you get sort of a false positive, false negative, where it's like your test passes, but it's not really invoking the code that you think it is. So you want to see your test fail first, and then what did he do? He made it pass. How did he make it pass? By having it returning 0. And I think as you pointed out, I was like, well, that's not really the score. Well, it is the score for that one test. And I think that's another sort of one of the things you have to put your mindset in, is that you do as little work as possible to get the test to pass. So, at that point, when you're just those couple of tests, all your application does is return 0. Is that what your application is going to do in the long term? No, but it's okay. So the whole idea is that test-driven development encourages baby steps. And baby steps in building your application that are then verified and backed up by automated tests. So it allows you to add incremental functionality and make sure that every step of the way what you're doing is correct and consistent with everything that came before it. Alternatively, and this is something that I did for many years, I would write my entire application. I'd have everything working. I'd be testing on the command line, and then I'd be like, oh, well, do I need to write some unit tests? Well, maybe I could. And I sort of did it after the fact, and then I'd always forget something. Or it's like I start writing some unit tests and realize, oh, wow, my logic was from like a half an hour ago was completely wrong. I was working under a whole bunch of incorrect assumptions. So I think what I've found is that test-driven development actually saves you time. Because it saves you time in debugging. It saves you time in having to go back and think about decisions that you made minutes or hours or days or weeks ago. So it gives you this nice sort of firm footing to work with. Any other questions or observations? Test-driven development? Okay, well, let's see some. So, oops, that wasn't a, it launched. So I have what's called, I think they just locked us in here. I don't know. Is that guy still talking? He's really loud. I have up here what I call Project Zero. This is like an optional assignment for anybody who wanted to start early or whatever, just get a little bit of Java in. And I'm going to use this to work through some test-driven development with you guys. And so there's one class that you need to implement called Student. It's got a constructor. It's got some it's got some parameters in the constructor. It has a couple of methods, and it's got a main method that takes the command line arguments. I'm going to scroll down there and sort of say, hey, listen, when you give it these command line arguments, it should print Dave has a GPA of 3.64 and is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. This used to be the first assignment many, many years ago, but then I decided that we didn't need it anymore and that we just use it as an example. So let's develop, we'll start tonight and maybe finish up next week. Let's develop this little application using test-driven development. So I'll create it from an archetype. So I'll copy this. Okay, we'll quit out of the cones. We'll go back up here and we'll create that archetype. It'll blow up because of the tilde. Right? Yep. And we'll fix the tilde. And it'll prompt me for some information. It'll say the group ID, so it'll be my group ID, CS410J Whitlock. Artifact ID will be student, I think is what it's all over here actually. Student, 1.0 snapshot, and then that. Sure, take the default version, and there's the package name. All good. And so if we go now to the student directory, we see we've got some stuff. Let's add it to GitHub. Git status. Cool. It's got a whopping 3 files. That pom.xml, that tells Maven what to do. And we'll take a look at it, actually. When we open up Intellij, and it's got student and a student test. So added files for the student, I'll capitalize that. Student application, well, student program for demonstrating how to type. Test-driven development. Oh, cool, he's vacuum cleaning. That's why he closed the door. What a nice guy. Okay. Cool. Okay, so now let's go back to IntelliJ, and we will open oh, weird. Okay, so we'll open. I can't open a new project. Sorry. I'm having a, I almost said senior moment. Oh God, I'm talking to my parents too much. I see some of you talk to your parents also. Where you talk to my parents, that would be weird. Okay, maybe it is just, how do you open recent? So I guess it's not an open project as opposed to open. That's actually kind of smart. Okay, so in my home directory, I'll go to my PSU directory. I wish I could just type it in. Come on, Macintosh. Oh, there we go. PSU, my Git directory. What order are these in? That makes no sense. Important say Java 2015. Student. Pom.xml. New project. I'll just reuse that same window. We're not going back to the cones tonight. Oh, just open the pom.xml. Oh, there it is. Okay, good. And it didn't register it with version control. Oops. Enable version control integration. It's part of Git. There, now it's happy. Okay. Take a quick look at that pom.xml. So you can learn more about this in the by watching the Maven lecture. But basically, this is giving Maven some information about the project. This was created from the archetype. All of the archetypes use a parent of, that is the parent project for all of my projects. It's an artifact called CS410J. This thing will tell it, like, always use Java 8 and a couple other sort of like global configurations for all the projects that you'll be doing in this class. For this particular project, we have information like the group ID, which we entered there on the command line when we created the artifact, and also the when we generated the project from the archetype. Also the artifact ID and the version. This thing creates a jar file. You guys know what a jar is? A Java archive. It's basically a bunch of class files all glommed together so it's easy to redistribute. And it also has some other information. I don't want to go into too much detail, but Maven has plugins which do work. It's a collection of what are called goals, which like perform a certain thing. Like a goal is like compile source code or build me a jar. Or in this case, yeah, like build me a jar, so the Maven Jar Plugin, and I can specify the main class for the manifest, which means that if I can make let's call it executable jar. We'll see that in a second. Oh, and then also Shade will go and take all of the dependencies. Actually, I wish there aren't any here, or are there? Oh, too much. Yeah, there are a bunch of dependencies. Yeah, of course there are. And glom them all into what's called an uber jar. So you only have one jar to execute instead of having to worry about putting additional dependencies on the class path. You guys know what the class path is, right? What's class path? It's the path's class. Okay, what's it?
The path to all your classes.
The path to all your classes? Yes. Where do you use the class path, and what uses the class path? Yes, the command line is the compiler. In order to compile source code, you need to tell the Java compiler a couple things. Where does the source code live? And besides that source code, is there any other code that it needs to compile against? And that would be like, like for instance here, where to go? I put a dependency, let's see here, student. So student is a subclass of a class called human, which is off in an examples.jar, which is in my Maven repository. So after you watch the Maven lecture, all that will make sense, I hope. And so I say that this project depends on this other project to get some of the classes that it needs. This will be a common theme through the course, that you'll be using my code in your projects, but you can't change my code. Okay. That'd make a terrible villain. Anyway. You can't use my code. Really. Okay. Yeah, and then so we need the examples to get the human class. There's also a special class called invoke main, which maybe we'll dig into more next time. Another couple of dependencies that we have, though, is the JUnit library. So you guys heard of JUnit? This is a set of a Java API, some annotations, some runner code to run unit tests, to author unit tests, and then run them. There's also another dependency that we use for tests called Hamcrest. Hamcrest is an anagram for matchers. Okay, someone was creative. Which lets you write assertion statements that are a little bit more readable than what you get from JUnit itself. And we'll see examples of all of that. Anyway, but those are the kinds of things. And there's a whole bunch of stuff about reporting, which I don't want to go into right now. Those are the kinds of things that you can configure with Maven. And so then to build your Maven project, you can go from the command line, and then you can give it something like Maven package, which will say, compile all my code, run all my tests, and build the artifact, which in this case is a jar file. So I'll run Maven package. Error. So failed to execute goal, the Maven compiler plugin, compile, compilation failure. Okay, so now it's telling me something. Constructor human in class human cannot be applied to the given types. Okay, looks like I need to change some code before I can get things to build all the way. So let's take a look at what we've got. We've got student test. Whoa, files to add to get. The hell is all that? Huh. None of that. No, thank you. Wonder what all that is. Excuse me, sorry. That did not look familiar to me. Oh, .idea and target and ds store. I think it's time to add some more stuff to my getignore file. I'm just going to copy that on the clipboard so it's easy for me to paste into the file. Oops. Okay, so like DS store, that's like what, some Macintosh thing? The file system? Oops, there we go. Probably just at the root. Okay, and so then, okay, so IntelliJ creates a .idea. So, oops, is that a question someone had? No. Target is the name of, so when Maven compiles source code, when it generates, when it does something and it generates output, like a class file or a jar file or whatever, it places it in a directory called target. Those are generated files. We do not want to include them in version control, so we'll ignore all of that also. Good to know. Now if I do a status, great. It doesn't say there's any new files to be added because they're all being ignored. And git ignore is the only thing that's modified, which is correct. So added some more files to be ignored. Git ignore. Awesome. Okay. Okay. A little freak out from IntelliJ there. Okay, so now I open up the student class. That's kind of weird. Oh, there it is. Okay, just thinking about it. That's messed up. Okay, and what is IntelliJ? Ooh, IntelliJ is not happy. I'm going to quit and start over again. Power save mode. No. That is odd. And luckily, it remembers the places that I've been recently. Okay, thinking about it. Oh, yeah, it gives you some nice tips of the day. Actually, these are pretty good. I would recommend that you take 5 minutes every time you start up to sort of thumb through them to learn about the IDE. It's the kind of things that will help you later on. You will definitely recoup the time that you spend going through the tips of the day. Okay, everything seems to be displaying better, so all happiness. Okay, so IntelliJ. Things are underlined in red. I see red underlines. I also see like red things over here. Tells me something red bad. So let's see what it's got here. Okay, so the first thing is this. It says no default constructor available in edu pdx cs410j lang human. What do you think that means? If we have it right, a constructor for what? For human. And what's human in this case? Right, the superclass of this class is human, and it's saying there's no default constructor. Sure, I believe you. So, so it would appear that it's trying to call the default constructor, the default by meaning 0 argument constructor of the superclass, and that's true. So we need to figure out what constructor to call. So how do you invoke a superclass's constructor? Super. Okay. And it's red there saying that, oh, okay, it's asking for something. It says human string in human cannot be applied to empty string. Ah, so it must take a string. Okay, how could I find this out? Well, I've got everything working. I might be able to go to the source code here. Oh, and well, it looks like it decompiled. It didn't have the source code working. I need to fix that. But it looks like it's got something called name. So it's able to decompile it and have something called name. Okay. Oh, look, I've got a name parameter. Well, let's send that up to the constructor. Another way to figure this out, actually, is to go to the API documentation, which I hope still works. API docs. Yep. So I generate API documentation Java docs for my classes. And let's see here. Human is in the CS410j lang package. And so let's go to CS4j lang. There is human. Aha! Constructor. String, name. Okay, doesn't tell me anything more than I already knew. But look, Java docs. You can find out about classes that aren't your own. Okay. Hey, look, all the red, that red went away. It's still underlined red. There's more red here. Oh, there's some yellow here. Parameter classes never use gender and GPA. That's true. That's probably something to come back to later, because I have red here. Okay, missing return statement. Aha, yes, this is not valid syntax, right? I have a method declaration and it doesn't do anything. Okay, so it's not compiling. What should this be implemented as? Yes.
Return a string. This class is too much work.
Yes. But yet, I just watched that Uncle Bob video and something doesn't feel right. It's like I should write a test first, but the code doesn't compile. So, okay, let's write a test. I'll come back to these main method ones in a second. Okay. Oh, so this is a test for student. So I'll make a new test, and let's see here. What functionality do I want to test here? Oops. So let's see here. All students say this class is too much work. Okay. So all students say this class is too much work. Okay. So what do I need to do? I'm going to need a student. Student equals new student. Oops, no. Student. And Control P displays the names of parameters to a method, which is probably also, where is that? See, I learned the keyboard shortcuts so long ago, I don't even know where the menus are anymore. Oh yeah, parameter info. Okay, good to know. Okay, and so what do I need? I need a string name. I need an array list of classes. Okay, new array list. I need a GPA, 1.23 is a double, and then a gender, male. Sure. Whatever. Okay, good. I've got a valid student. I want to say that all students say this class is too much work. Okay, so now I want to have an assert statement. Assert that. So assert that, this is part of that Hamcrest API. The nice thing about assert that is that you can say assert that actual like equals to something. So this class is too much work. Oh, I'm sorry, other way around. No, that's right. Assert that student.says equal to this class is too much work. Okay, so I find that this reads a lot better than the JUnit style assert methods. I talk more about Hamcrest in the JUnit lecture. Okay, I wrote a test, and I like it. So let's run them. So I right-click on that, said Run Student Test, which is Control-Shift-F10. I'll remember that for later. Okay. So I run the test. I'm running them inside Intellij. Oh, and it's blowing up. It's saying, oh yeah, right. Code doesn't compile yet. Can't run your tests. Okay, what should I write here? Really? Is that? Why would I want it? Why? Heavens to Murgatroyd is what he was saying. Why would I want to have returned null? Okay. I want to see you fail. Yes. Okay. Okay. That's good. Oh, and it's complaining and it's doing something else. Return toString. This doesn't compile. I could have this return null, but you know what? I want to make an even stronger statement about the fact that this isn't ready for testing. I'm going to have it throw a new unsupported operation exception. Unsupported operation exception saying not implemented yet. Why would I want to do that? Right. So, like, if my code happens to invoke it, if you're doing test driven development, it's like you shouldn't be invoking it yet. And so you want it to blow up. You want it to be very obvious. It's like, wait a second, nope, I haven't implemented this code yet. I shouldn't be called. So now if I do try to do that, it'll break. Okay. So I'll run my tests again. Oh, that's not what I wanted. Or was it? We'll try that again. Go back to student test. I'm going to do the Control-Shift-F10. It's running it. Oh, all sorts of things blow up. Okay. But this is good. Assertion error. Expected, this class is too much work but was null. And look, you can get more details. Click to see the difference. Okay, that's nice. Okay, now from here I can navigate back to my student test and say, oh yeah, right, okay. Hey, I'm red. Now what do I need to do? Make it green. Okay, so what should I have this say? Yep, so now return this class is too much work. Run it again. Hey, it passed. Excellent. Okay, it was red, now it's green. What should I do now? Yeah, refactor. Anybody see any opportunity for refactoring stuff? Anything in there, anything in the test?
How do you know if you have something to refactor or not?
Yeah, he didn't really go into that. So for me, like the first thing you look for is code duplication, right? So if you've got like, this logic here is like the exact same code doing the same kind of thing, that's a place for a factor. If you've got a big code block which is too long, anything longer than like obviously a screen length, but even there's a school of thought that says a method should be like no longer than like 5 or 10 lines. That would be another place to say, hey, listen, can I break this like big piece of code into smaller chunks, maybe with nice names to talk about things?
So does clicking refactor give you the suggestion?
No, with a refactor, well, that's a very good question. So let's just take a look at what's here in the refactor method, the refactor menu. Actually, one of my favorite things about Intellij is this refactoring tools. They've done a really good job, as a matter of fact, I think way better than Eclipse, in terms of like giving you useful refactorings that actually do things. The refactor this, I'm not too sure what it does, but you can do things like renaming. So let's say, actually, yeah. Unfortunately, I think I picked a pretty good name for this test. But maybe sometimes you want to rename your test now that you have a better idea of what it is, or renaming methods in your code. Here again, right now at this point, it's a pretty small application. There's not too much to change. But yeah, so I guess I would look for code to be duplicated, code that could be it could have methods extracted from it. So you can use like the extract method. So you highlight a bunch of code and say, hey, turn this code into a method. And the IDE will figure out, okay, great, what code needs to be there? Are there any parameters that get passed in, or what about the return value? And then also naming. Are your variables well named? So as you get everything to work, then you look, it's like, wow, is this readable? So if I came back to this and 5 minutes, 5 days, 5 weeks, 5 months later, would I still understand? So those are, I think.
If I change the variable name, I would then hit refactor, and every time that variable name occurs,
Yes, right. And that's the nice thing about the tools, right? It's smart enough to know, hey, a variable or like a method name, right? I changed the method name in this class, and Intellij knows everywhere that method is used, and so it'll rename everything. And so it'll do that, and then what do? Right, you compile and rerun your tests again, right? And so you've got this test that then, and you want to make sure it passes, because every once in a while you do a refactoring or you name something and something breaks. So yeah. And we'll see some more examples of that as we get deeper into the application. Okay, so I don't see anything to refactor. Do you guys? No? Yeah, okay. So I am going to commit my code. So I guess the things that he didn't talk about, something that I like to do, is my application's in a good state. Everything passes, right? I like to commit every time that things are stable. So if things get unstable, I can go back and sort of start over again, right? I think we've all done it, where it's like you make a bunch of changes and then you're like, oh, things are just so messed up and they were so good just 5 minutes ago. Oh, what did I do? And you're doing undo in your editor and everything. Well, sometimes it's just easier just to revert your changes, but you can only do that if you save things off to your source control. So got a simple test working. Okay, I'm not going to bother pushing it off. Okay, let's do another one, and then I think it's almost time for a break. Okay, so great. Everything is passing. What is the next test that we need to write? Let's go back to the assignment. Ultimately, we want something like this. right? When you pass in this information, you want to have, let's see here, I think it's the toString method. Yeah, return that. So I think really the bulk of this program is to implement that toString method to return something. So let's see if we can, let's write like the be-all, end-all test, and then we'll come back and add the pieces parts later, because we won't be able to pass. We'll build lots of things up. So let's see here. Let's just take that one. We're going to copy it and then just like put it into the, just write a test that does all of that. So then we can build it up from there. Oops. So student, oops, student toString of Dave male 3.64 GPA algorithms operating. Yeah, I don't know if I like this method name or not. I mean, it's sort of, it's very explicit, but it's like, ugh. Okay, so what do I need to do there? Student. Oh, I'm gonna call him Dave. New student. Okay, the name is going to be like Dave. Classes. It's 3 classes. So, okay, and I want that array list. Well, we'll come back to that. GPA is going to be 3.64. Gender is going to be male. Okay. Well, this compiles, but the classes is not correct. So I'm going to use a refactoring. I'm going to highlight this code, and I'm going to say refactor, and I'm going to say introduce extract. There you go. Extract variable, which is option command V in the future. Okay. So it makes an array list. Because the name of the parameter in the student constructor was classes, it defaults to the name of classes. Yeah, that's kind of nice. And then it initializes it to that value. Oh, cool. That saves me a bunch of typing. Okay, and now I'm going to populate that classes array list by adding, what, algorithms. And I'm going to add operating systems. And I'm going to add Java. Okay, so now I think I've set up the data for my program. Okay, now I need to add. I need to make a test. So what am I going to test?
Assert that the student's toString matches.
Yeah. So the Dave.toString equal to the thing from the assignment. That big old string. Oh, don't you love IntelliJ? It does things like automatically put the backslashes in. It was too long, and so is there supposed to be a new line there? No. Okay, so there was a new line from the PDF, and so I got to put this all in one big line. Is that really hard to read? Now I wonder if is it smart enough to say? Oops. Is it smart enough to say? No, it's not like split this over 2 lines. That's a really big line, right? Okay. Anyway, okay, cool. This is my test, right? Ultimately, I want this thing to pass. Let's run it. Oh yeah, right. Not implemented yet because I haven't implemented it. Whew. Okay. There's a lot to implement here. What are some? So before we can implement all of this, is there a baby step that we can take? Have what return a bad value? Well, it's kind of already doing that, right? Oh, I see what you're saying. Have it return something instead of.
Return string, but the wrong string.
Okay, yeah, sure. I guess we can do that. So, like what? Yeah. Hello. Okay. So yeah. So it's we know that much. Okay. So maybe we should build it up. So this is ultimately where we want to be. So this test, I kind of want to put it on a shelf, so I'm gonna ignore it for now. It's cool that we have it because it's kind of like this is where we want to get to. But let's take a couple of small steps after we take a break. So let's take another 10. Be thinking about maybe a couple of small test cases that we can write. We'll put this to bed after a break. We'll talk about the first project, and then that'll be it. So 10 minutes. Thanks.